Excuse the
sometimes
interruption.
we get
Can we get all grade
interrupted.
9s with last name M to P? Please go to the gym for photos. That's all grade 9 students, last name M to P, to the gym for photos.
Sometimes we hit a fire alarm and I don't accidentally pause it, so there's like a fire that happens during videos where it's really quiet for 10 minutes. And so I try to pause things and move things along, but it's very informal that way. When I started doing them, I thought I had to do things really formally because it's going on YouTube. And this is a boring conversation to listen to on YouTube. But I realized that made it not as much fun to teach. So I still like to have fun while I teach. So my videos are very informal that way. Now the way that your textbook works is your textbook has a lesson, right? This is chapter 3, we're in lesson 1, and it has a getting started, a construct the understanding, and then goes into acceptance. The getting started generally connects to something you've learned in the past that's going to help you learn what we're doing right now. The construct the understanding usually lets you discover some things on your own. Sometimes I really like them and we do them both. Sometimes I like one but not the other. And sometimes I'm like, nope, we're going to skip. But I like this one to start off with. We'll do the getting started together. The thing that you're going to notice is I also use different colors to help you learn better. And sometimes in your notes, you might like to have different colors. So you would for sure want to have a red pen, but maybe you have a black pen, a blue pen, maybe you like fancy stuff and you like have green and purple and orange and all sorts of pens. But when we look back at our notes, and an example for this one here, we're going to look at, and I'm going to do this one in blue. I'm going to write the equation here in blue. It says if q is equal to 3 and you had y equals x squared plus q, what would its graph look like? What would it be compared to the original graph of y equals x squared, which on my graph here is in red, so I'm going to put a red box around that. If we color code things, then later when we're studying, it's going to make our brain see connections quicker, which saves you some time. So here, I'm going to think back, well, if I think back to grade 11, or did you have, no, it was P and Q. There we go. Here's your grade 11 formula for a parabola, and P and Q are your vertex. So according to this in grade 11, your vertex would be at 0, 3. And in grade 11, you would say the A value is 1, so I go over 1, up 1, over 1, up 1, and my parabola looks like this. In grade 12, we're developing a pattern of, from the colored papers that you guys did. We did 4 colored papers. For the grade 12s, you missed 2 of them. You've got to make sure that you get answers from a grade 11 in the class or work through them on your own. On those papers, we discovered that some things got moved left, some things got moved right, some things got moved up, and some things got moved down. And the language that I'm going to start using is sometimes a number is inside a function and sometimes a number is outside of the function. So in this case, talking in grade 12 terms, my function is x squared. This plus 3 happens after or outside of the x squared. That 3 doesn't get squared at all. It happens outside. Everything that's outside moves things either up or down. And in this case, that plus 3 took my original graph. Can you see it's just been shifted up 3 units? Switching colors, if I had a minus 3 here, in grade 11 math, you would now say, oh, my vertex is at 0, -3, up 1, over 1, up 1, over 3. And you would get your points in grade 11 math this way. In grade 12, we'd say, hey, this minus 3 is outside of the function. That's taking my original graph and moving it down 3 units. And here we can see, now that I've got two graphs on the same thing, the color coding is really nice. Because I can immediately say, oh, the blue graph goes with the blue writing. The green graph goes with the green writing. If I'm looking at this later while I'm going through my notes, my brain is going to be able to make all of those connections quickly. Next, we're looking at values inside. So I'm going to change to purple next. Y equals x minus h, and if it was a minus 3 minus a negative 3 would make this a plus 3 squared. And this number is inside the function. That 3 is getting squared. Anything that's inside from your colored papers, see if you can see that pattern. When things were inside, it moved left and it moved right. And this plus 3, if you used your grade 11 math, you would have said, I have a vertex at minus 3 comma 0, over 1, up 1, over 1, up 3. Using our new grade 12 method, we would just say the original graph has been moved 3 to the left. Things that are inside always move horizontally. They affect the x. And sometimes we'll say, well, and everything inside is sort of opposite of what you would think. If you would see plus 3, your gut would probably say, I want to go 3 to the right. But the x's are liars. They lie to you. They'll always go the opposite direction. And the reason they go the opposite direction is, well, originally, my vertex has a y value of 0. What x value gives you 0 now? Well, the x value would be the opposite of this. Minus 3 plus 3 now gives you 0. So that's why it moves in the opposite direction. And finally, oh, I need a new color. I'm going to create a new color, maybe. I like orange. I don't want a dotted line. Yeah, that looks. That's too. Is that too thick? Maybe this one. See if I like that. Oh yeah. X minus 4 squared. So now, in grade 11, you would say the vertex is at 4 comma 0. Over 1, up 1, over 1, up 3, and have your parabola this way from grade 11. In grade 12, we would say that 4 is inside the function. It affects the x. X's are liars. It's going to go 4 to the right instead of 4 to the left. And so having all 4 of these graphs, if I decided for you guys that I had really liked the color black and did everything in black, then my final graph would look very congested. In fact, that is why we are going to skip. Look on yours. I have a bunch of colors. Do you have colors on yours? No. That is way, even with colors, man, get a little dizzy looking at that. We're going to skip this because it's too much, too busy. And we're going to be able to learn no problem with the examples that we've done so far to move on. Okay? So what's going to happen in your notes is sometimes prior to getting to the first example, the textbook has explained a few things. This is a good little review for us, right? If we had the square root of x plus 2, do you see that that 2 is outside? Our square root graph was, what color was it, green paper? Yeah? So does it make sense that that plus 2 outside moves it up 2, which just changes your graph up to there? And if we had a minus 1, it moves it down 1. Okay? Now the first thing I just want to point out with this is sometimes they give you this. I'm going to put a blue box around this because that's our blue graph. Can you see what I did to the equation? Are those two equations the same? Or did I completely change it? Does it mean the same thing or does it mean something different? Okay? So what happened? This one has a +2 here. This one has a -2 there. Could I change this one to equal? Are they equal? I just moved the 2 to the other side, didn't I? Could you do that? Could you subtract 2 to move it to the other side? Yes. So sometimes you'll get an equation where the 2 is on the other side. For me personally, I like the y by itself, but you'll see sometimes the number's on the side of the y. You just have to move it over. So this equation would be the same thing, just same thing if I had y + 1. I would first take the time to move it to the other side and then realize, okay, that moves it up and down and so on. Okay? Language-wise, we call this moving up and down, and this is another thing I'll get you to bring along, is a highlighter. Because when the textbook has stuff, maybe there's certain words we want to highlight. So this is moving things left, right, and up and down are called translations. So that is, if we have to describe something, we can write it as translations. And you can see here is where they put the +1 and the -2 on the other side. So let's quickly look at, here's our execute graph, which was our white paper. In the textbook has drawn all of these graphs using a computer program. And when they cut off the graph just ends. When you draw a graph, you have to put arrowheads on the end of your graph to show that it keeps going forever. If you forget arrowheads on the end of your graph, the grade 12 pre-calculus exam has an error code for that. It is called an E9 error. If you make an E9 error on your exam, they bubble in an E9 and take off a half a mark. There are 10 E errors that we are going to learn throughout the course of this year. Every time you make them, I will write on your question, E9, E2. Some of them are hard to do. Like an E1 is just deciding not to write your final answer. So you're doing your work, and you get 7 + 3, and you just decide you don't want to write 10, and stop. Then I have to give you an E1 error for not finishing the question, even though you probably could do it. That was a hard one to get because it's pretty hard to not write a final answer, but that's E1 error. Forgetting the arrowheads on a graph is an E9 error. So, if you did x + 2, now this is inside. X's are liars. Does it make sense that that would go 2 to the left? And if you have an x - 3, X's are liars, that'll go 3 to the right. So we've got our way of describing it. So they will ask you, can you describe these things in words? This is describing it in words. Horizontal translation, 2 units to the left. Or horizontal translation, 3 units to the right. And sometimes they try to generalize things in these color things. Sometimes I will say this is really, really good information. This one we're going to skip. And we're going to go to our first example. Now, in your textbook, the textbook has given you an example and has worked it out. So this is what you would do if you were taking a university class and sometimes you go to university and a teacher has an accent and you cannot understand anything they are saying. This happens. So then you're like, okay, I will just read my textbook. So the textbook has an answer for you. The problem with a textbook is their answer has to explain everything to you. And you have to wonder, well, what would I have to show if do I have to write all of this? Like if I did this question, do I have to write everything that they've written down? what do I need to show? So what we're going to do is every question has an example. You can read it over on your own if you like, either before class or after, but we're going to do the question that's off to the side. And off to the side, it has the question and a column underneath. This is where you're going to show all of your work, and that's how this textbook becomes your notes. We're going to do this question together. So here's the graph of g of x. Sketch the image graph after each translation. Write the equation of the image graph in terms of the function g. State the domain and range of each function. So we're going to do I'm going to do it in blue. We want to go 4 units to the left. Take this point, 1, 2, 3, 4. 1, 2, 3, 4. And connect the dots. And we've got our graph. And this might happen to you on questions on quizzes and tests as well. So I'm going to talk to you a little bit about reading in a math class. Reading in a math class is different than reading in an English class and different than reading in a geography class. For example, in a math class, once you have done a question, make sure you read the question again, because you might have missed something. Okay? I was reading the question, I got to translation 4 to the left, I moved it 4 to the left. Is this the only thing the question is asking? No, it's asking more. But sometimes we do something and we get so excited about finishing, we just move on. So reading on a math test or a math quiz, after you're done a question, you should read it again. Make sure you've done everything. So sketch the image. We did that. Check mark. I did that. Write the equation of the function in terms of the function g. Okay, so I'm going to highlight this part because this is very confusing language for a lot of people. What does it mean when something says in terms of? Okay? In terms of, this means that g must be on the right side of the equation. So you need to write an equation, and if it says in terms of something, you know that whatever they say in terms of needs to be on the right-hand side. So how do I write an equation for this graph? The original graph was y equals g of x. That's the red one. My blue graph is the same graph, but it has been moved to the left. Moving left and right is with horizontal, that's with x. X's were liars. X's was always something inside. So in function notation, I would write this like this. Here's my g on the right-hand side. X's are liars. We have moved 4 to the left. So to show that, would I have a +4 or a -4 inside the bracket? A +4. And it would be inside because it moves it left to right. Now I don't know the actual equation of this red graph, but I do know the function equation of this graph. And so I would show the same thing. Inside, I have a +4 of g of x. Again, I finish again. I reread the question again. State the domain and range. The domain in interval notation and in set notation. In set notation, we go to our smallest value, which is -5. It includes that. The x values are between -5 and my biggest value is 2. In interval notation, I would use a square bracket and say I'm starting at -5 and I'm going to 2 and end with a square bracket. The square brackets say the point is included in the domain. In interval notation, we use round brackets when we have asymptotes, like we did on the blue page, to say that it isn't included. and our range. Smallest y value. So again, when you're thinking about domain and range, often think about smallest and biggest. Domain is my x values. Range is my y values. What is my smallest y value? It's going to be 2. So in set notation, it goes from 2, it includes everything, and my biggest y value is 5. In interval notation, you would write it like this. Do you have to know both of them? Yes, but if the question asked you for the domain, you have the choice. You could choose either to do the interval notation or the set notation, okay? The reason you have to know both is if you had a multiple choice question and they gave you a domain, you have to be able to read it whether it's in one notation or the other, okay? Sort of rule of thumb is if a question starts with one type of notation, then you would answer in the same kind of notation, but you wouldn't lose marks if you decided to change notations. They're kind of like different languages, right? So if you're, I don't know, you're in French immersion, but you're taking a geography class in English, and your question was in English, your teacher's probably expecting you to answer in English. Would it be wrong if you had the right answer in French? No. But would your teacher maybe get annoyed? Maybe. Question or?
That was the question.
That was the question. Perfect. Okay, so now I read the question again. I sketched the image. I wrote the equation down in terms of the function g, and I did the domain and the range of the function. Whew. Okay? This is why reading in math is different than reading in English. Okay? When you get an English novel, does anybody read it and then read it again and then read it again? We read our question 4 times now. Anybody get an English novel and read it 4 times? No. You probably only read it once. Right? And then sometimes if you're like, I'm just going to pick on geography right now. If someone says to read something in geography, maybe you've learned this skill in university. Some textbooks, you're like, I can read the first sentence and the last sentence of a paragraph and skip the middle. And get the basic idea of what's happening by just reading little parts of it. Math is different. You have to read every single word, and you'll probably have to read it more than once. So that's part A. Part B, I'm going to switch to green. We want to go 1 unit up. I'm going to take my original graph, 1 up, take every point and shift them all 1 up, and then connect the dots. So much fun. We get our green graph shifted up 1 unit. We have to write the equation in terms of g, and this time it will be outside the function. So there's my function. And I just need to write a +1 outside. And the y's are not liars. Moving things up and down is exactly how you think about it. So we have a +1. Domain. Again, smallest x value -1. Biggest x value is 6. I'm just going to do the interval notation for this one, and our range. Smallest y value is 3, and biggest y value is 6. So we can see that from our graph as well. Now, one thing I'm going to do is after we've done a question, so we just finished this question, then right above the question, I'm going to get you to write down 4, 5, 6, and 7. Because now these are the questions from the practice that you should be able to do. After just doing this one example, you can now do questions 4, 5, 6, and 7. The next thing I'm going to get you to do is after writing 4, 5, 6, and 7, turn to page 169, and then circle number 4, circle number 5, turn to page 170, circle 6, and circle 7. Those are the questions that you're expected to do outside of class to practice, to make sure that you're understanding things, okay? Later on, when you look at your homework, if you see something circled and it's not done, it's sort of like, oh, I should still probably try this one. I should practice it. So we circle it to give us a reminder of which one we should do. If you get stuck on a question, when you go back to question 1, you're like, oh, there might be something in question 1 that's going to help me with questions 4, 5, 6, and 7.
Sorry for the interruption. All grade 9 students with last names starting with Q and R, please head to the gym right now for pictures.